Hi everyone. So today I will be showing you how you can write a smart contract, deploy it on Base, and test it. I'll try to do it very, very quickly in under 10 minutes. Let's go. So the first thing you do is you should go to remix.ethereum.org, right? And then you create a new workspace. So when you click on create a new workspace, you should create a basic workspace. So I already have a workspace here. It's a basic workspace. It's what you would get if you create a new workspace. So I think, yeah, you should start from there. You can also start from the ERC 721, but I want to show you everything about what we're trying to do here. So I'll just start from this blank workspace. And so first things first, let's delete these contracts set here. So let's delete the second one. Let's delete the third one, and we will just keep the storage. I will rename this to NFT or ERC 721 mintable. That's what I will rename it to. And then here I will say contract ERC 721 mintable. And we'll start working on this. I will delete everything in here because it does not matter. And this too as well. I think let's keep the standard comment in. So title ERC 721 mintable dev. It's a mintable ERC 721 contract. And I think that will be it. So for now, we will keep it so simple. The first thing I will do is that we're not going to start from scratch to build an NFT contract, right? We have some the contracts that most of the people in the industry use that are, usually open Zeppelin contracts are ones that are pretty much often used for ERC20 and ERC 721. So that's what we will do. We will create a very simple ERC 721, so an NFT contract that anyone can mint from if they pay a certain amount of USDC. I think that should be the way to do it. So for that to happen, what I will do is I will import, I will import OpenZeppelin. So it tells you, okay, this is good. So we can see here contracts. I think there's there's a folder called token, exactly, and then ERC 721. I do believe it does exist. So there's here. So this is the contract we want to import. Another thing you want to import is the interface, and the interface is the way through which we get to interact with other contracts. So if you're trying to inherit, what I will do here is you will see ERC 721, ERC 721 mintable. Okay, yeah. One thing about Solidity is that you have to put the import. Okay, yeah, we will work through that in a little bit. Okay, so we imported the ERC 721. Now what we will do is with that, we will import an interface to interact with the ERC 20, which is USDC. So that would be Zeppelin contracts, and then I think it's interfaces, and then ERC 20. Exactly. So this is the way to do it. And then now that we have this, the way you can think about smart contracts is that they are almost like classes in JavaScript. And so what you need to do is we need a constructor, actually. We need a constructor here, and we have some some good constructor. Okay, this is interesting. So the ERC 721 itself as a contract, let me see, the depths. If you go to the depths, npm at OpenZeppelin, token, ERC 721, So ERC 7921 is itself as a contract, it takes two variables in the constructor. So we need to pass that. So as you can see here in the ERC 721 mintable, we are inheriting all the properties of ERC 721. And so one of them is the constructor. And so that's where this error comes from. If you can see here, it says no arguments passed to the base constructor. So we need to pass arguments to the base constructor. How do you do that? You do something like this, okay? So this is a good enough suggestion from the AI. This is a good enough suggestion from the AI, but what I want to do even better than this is I will do something like this. I think, we can take these and we can pass them again in our constructor. And then here, what we will do is that we will pass. Yes. Okay. So this should work. So what I did here is that, whatever the ERC 721 constructor needs, I am passing it to my constructor. So whoever is going to be creating this ERC 721 mintable contract will decide what would be the name and symbol for the NFT. And so you might be wondering, like, why are we recreating another 721? Why are we creating another NFT? And so the reason for that is because the ERC 721 standard, as it is written by OpenZeppelin here, only has a bunch of functions, and none of them are necessarily a mint function that allows you to mint from outside of the contract. So let me explain. If you look at some of the functions here, a lot of the functions here are, public view. So this makes the difference whether this function shows to people from outside the contract where you can interact with it, or whether the only way to call this function is from the contract itself. And so as you can see here, some of the functions here are internal, and one of the functions that are internal is mint. And so one of the things that actually cool about Solidity is that if it's an internal function, usually it starts with an underscore. So as you can see here, the mint function starts with underscore, and so underscore mint is what allows us to know it's internal, but mostly is the fact that it's written internal here. Okay, so this function is internal. I don't think there's any other function here that is a mint that's external. So we have another one called safe mint, which is also internal. And so how do you use these functions if they are internal? There's a reason why they're internal and why they are there. And so the way to do that is we will create a function. We will call it mint. This is not too bad. Yeah, mint address to. So where do you want to mint it to? And then a token ID. I would say, yeah, let's say that you have to specify the token ID. And so for that, what I will do is that I will just call the function mint. Remember, the function mint already exists in this contract because we are inheriting all the functions of the previous ERC 721 contract. And so the way to do this is mint to token, and then yeah, we can set the token IRI. So that's I'm not gonna go there. This is an interesting suggestion from the AI, but for now I will just keep it this way. If you do this actually, and we close the function, so this should allow us to. So first of all, this compiles, and I click Command S. You can see here it compiles. You can click compile. It compiles, so it works. And so this allows us to deploy an ERC 721 that anyone can mint from. There are no restrictions on who can mint. It does not ask you to send USDC before you can mint. But I'll do something else here, which will get us into the territory of above 10 minutes, but it's okay. I think it is worth it. And so the way this will be done is I will create an ERC20. Let's call it USDC So this will be USDC contract. It's going to be an IRC20 USDC contract. So I think this could be public, immutable. No, it doesn't have to be mutable. And yeah, I think this should be it. And let me create another function, call it set. Okay, let me just hard code the USDC. Don't do this. It's not good. Don't hard code the USDC contract. The way to do it is you should set a function, let's say that says set USDC, and it takes, an address and USDC, and then what it does here is that it will do something like USDC takes IRC20 USDC, and then we close it, and that's it. So usually you should set this function, and hopefully it's only owner or something like that. So this is not, configured. But for now, so that I don't go too deep into the rabbit hole, what I will do is I will hard code the USDC. Okay, and so for that, it will be something like this, IRC20. And then we do this. I think this should work. So this is USDC on Base Sepolia, where we will be deploying our contract. So for now, it's a contract that mints regardless of whether or not you did send a USDC transfer. So USDC. So this is something also that's interesting because USDC has 6 decimals. So let's assume that we're asking for 1 USDC. USDC has 6 decimals. I think this is something that, if you look at the USDC tracker here, yes. So as you can see, I'm going to show you here the USDC contracts on Base Sepolia. It says that it has 6 decimals. There's a different way to look at it too. You can try to read the contract here. And I think there must be a decimals. Yes, there's a decimals function, and it's 6 decimals. So when it's 6 decimals, the way that Solidity works, there are no decimals. You will have a representation in UEnt, so in signed integers, and so this is the representation of 1 USDC in Solidity. It's 1 million units of small units of USDC, and so that's how it works. So what did you write here? What did the AI actually help us write here? And what we did is that we have require USDC.transfer from. So we're transferring from the message sender, the person that's, making the call, to the address of the contract. We're transferring 1 USDC for every mint. Now you can think of a way to recoup this money that gets accumulated in the contract. You can route the USDC to a different address. Again, we're not playing by the book here. We're trying to do everything very quickly, and so we're just going to send the USDC to this contract. And so for now, this should be good. Now you can actually deploy the contract, and for that, what we will do, we'll try to deploy it to Base Sepolia. I think hopefully at some point we get to have better support for smart wallets at Remix, including being able to switch the chain from Remix itself or using Create2 instead of Create. But for now, we will use MetaMask EOA. And so let's see. So I think it's already set on Base Sepolia. I have some ETH. And so it allows you to deploy and verify. You get to verify on Explorers. If you add the API, Etherscan API key, you can go set it in the settings panel. I think it's somewhere here. Where is it? Yeah, I think it's here. You get to set the API address, the API key for Etherscan if you want. But for now, I think this comes from here. Yeah, exactly. Access token. You can create a new API key and save it, and that would verify on Etherscan. I'm not going to do that. I'm going to show you another one, which is Certify, that I discovered lately that was actually pretty cool. So let me choose the name and the symbol. I will be putting base and base here at both, and I will transact very simply, and it will prompt me to deploy the contract. So I'll wait for the contract to be deployed here. Let's see. It is being created, and here we are. So we have the contract here, ERC 721 mintable, and we will be able to mint. Before we are able to mint, so let's actually try to mint here to my address, try to mint token 0. And as you can see here, there's an error, execution reverted, ERC20 transfer amount exceeds allowance. So what this means is that we need an approval to the contract, to the ERC 721 mintable contract, before we are able to move USDC from my wallet to the contract's wallet. And so I will hit send transaction anyway, and you will see that the transaction will fail. So as you can see here, the transaction fails miserably because it exceeds the allowance. So one thing that I noticed also is that in this contract, I thought I put 1 USDC, I actually put 10 USDC. So let me get some USDC faucet for me to be able to pay for this NFT contract, and I'll be back. Okay, so I want to show you here how to do that. You go to faucet.circle.com and you get some USDC Sepolia. So we're getting 10 USDC, exactly what we need for us to pay for this NFT mint. So how do I call the approve function? Where is it? So the approve function is on the USDC on Base Sepolia. And so I need to get the USDC contract address, and I will load it. So I will load an interface of USDC contract address so that I can interact with it from Remix itself. Another way, obviously, you can interact with that contract is through the Explorer itself. So you can go to contract, write as proxy, and you can, interact here through approve. I will do it through Remix. Okay, so let's go back to Remix. I will load the IRC20 contract here. They have this cool function where you could do add address, which allows you to interact with a deployed contract. So I load the ERC20 contract here, and I can hit approve. Who's going to be the spender? Well, the spender is going to be the ERC 721 mintable contract. And then how much value am I going to allow it to spend? It's going to be 10 USDC, which is 1 and then 7 zeros. Because as you remember, USDC has 6 decimals. So these are the decimals, and this is the USDC. It's 10 USDC with 6 decimals. So I will hit transact here, and let's see. So yeah, this actually, you're giving someone else permission to spend this amount from your account. And so I will just hit transact here. Done. Transacted. Cool. Great. Now that this has been done, I should be able to go back to my ERC 721 mintable and be able to mint. Let's see if it works. And lo and behold, it seems to be working. I didn't get a message that says that the allowance is exceeded. So here, and let's see if the mint, so the mint contract is pinned in. I'm not sure if it went through. Yes. So this is the transaction went through. All good. Perfect. Nothing wrong with this. Yeah, amazing. And as I can see here, if I go and actually take a look at the ERC 7921 contract that I have, as you can see, there was a mint call. So the first mint call failed and the second mint call succeeded. So yeah, this is how you can run your test. This is how you can deploy a simple contract. I will be sharing the Sourceify link, is what I discovered from Remix lately. And so it has everything you need. It has the code. I'll share this in the comments of this video. Thank you everyone for watching. And yeah, this was not exactly 10 minutes, but I hope it was resourceful and helpful for you to learn or start learning some smart contracts development. Let me know if you like this kind of content. Let me know if you like this kind of content. I can do more of it, and appreciate you watching to this point. See you soon.